Okay, inverse matrices means we are going to find this A inverse. Before this, we have our addition, multiplication. Hasil tambah, hasil darab, tapi tak pernah buat lagi hasil bahagi kan? So, dia tak ada konsep hasil bahagi, tetapi dia ada konsep of inverse matrices. So, for our matrices 3 by 3, if you want to find the inverse of matrix, we have three methods. The first one is adjoint method, which is using the adjoint matrix that we learned before. Secondly, we use the properties of identity, where you found that your multiplication of matrices, you have identity properties. Lastly will be ERO, elementary row operation. So for inverse of matrices, not every matrix it will be able to inverse. So it will depends on its determinant. If we find the determinant is 0, means that matrices cannot be inverse. The inverse matrix does not exist. Alright, so that matrix we'll call it singular matrix. Not every matrix is able to find it A inverse. So this depends on its determinant. Determinant 0, that matrix is singular. It won't have the inverse matrix. If your determinant got value not equal to 0, means that matrix can be able to find it inverse. Because finding A inverse, you will be using adjoint method. Adjoint formula will be 1 over determinant times adjoint matrix. So you just imagine if your determinant here is 0, penyebut kamu kosong, it will be undefined, right? 1 over 0 undefined, right? Means your A inverse does not exist. So this is the formula for finding your inverse matrix 3 by 3. We can revise back. Last time, your SPM matrices of 2 by 2, your formula just 1 over determinant. Here change place on it. AD, then negative, negative. Actually, this is your adjoint for 2 by 2. Okay, this is your adjoint for 2 by 2. So it just revise back 2 by 2 matrix first. To find A inverse, 1 over determinant A, then position A and D exchange, position for B and C put in negative. So what's your determinant for A? Determinant for 3, 1, 5, 4. AD minus BC lah, right? AD minus BC. Finding its determinant, so you can notice that this determinant will have value, means it will have inverse. So what is the inverse? Inverse matrix will be 1 over determinant. Put in your adjoint matrix. This is your adjoint matrix for 2 by 2. A and D change position. B and C put in negative. So your inverse matrix multiply in. This is 4 over 7. Negative 1 over 7. Negative 5 over 7. 3 over 7. For question B, we find its determinant first. Determinant for 2, 6, 1, 3. So it will be 6 minus 6. It will be equal to 0. When we found our determinant 0, A inverse does not exist because this is not denoted by A. This is denoted by B. This matrices is denoted by B. B inverse does not exist because B is a singular matrix. So what we're doing here is finding the inverse using adjoint concept. So actually you learn, but you don't know this is called adjoint.